Now, this is a problem that's a slightly more complicated one, because we're not going right on the compass directions. It says here a plane is flying with a speed of 280 miles per hour, 35 degrees south of west. The wind is blowing 50 miles an hour at 23 degrees south of east. What's the plane's velocity relative to the ground? Well, you can try this by graphing. One way you can do it is just get a protractor, get a ruler, and very carefully just draw these vectors. Draw this one that's southwest, like that, and then the other one is a little bit shorter, and it's southeast, and then just draw and measure that vector that goes from the tail of the first to the tip of the second one. So that's one thing you can do, and you should give that a try. So stop the video, grab yourself a protractor and a ruler, and draw this and see what you come up with.
Well, at first I'm going to do this really old school with just a blank piece of paper and a protractor and a ruler as my tools. I'm going to use a Sharpie to draw so it shows up a little bit better here, but you would probably use a pencil because you could erase mistakes better. I've already established a north, south, and east to west, as you can see here. That's easy to do. You just draw a line, make a 90-degree to it with a protractor, and just draw another line, and it's just establish what you're going to call north, south, east, and west. Now, if I look at my problem, it says a plane is flying with a speed of 280 miles per hour, 35 degrees south of west. So I'm going to take my protractor and put it right on the center, going south from west, 35 degrees. I'll make a little mark there. So I'm going to draw a line that starts at my origin, so I'm going to put the 0 part of my ruler there, and make it to scale 280 miles per hour. Well, I'm on the millimeter side. I would use 280 millimeters, but it won't fit on the paper, so I'm going to use half scale. So I'm going to go up to 140 millimeters. So I'll carefully draw my line here, back to the origin, and that's my first vector. That's 280 at 35 degrees south of west. Now it says the next vector, the wind vector, is 23 degrees south of east. So I have to establish down here at the tip of this vector, I have to establish what's east-west again. So I need a parallel line. It's easier to do than you might think. If this is 35 degrees, then a parallel line off here would also have a 35-degree angle here. So what I have to do is take my protractor, lay it down here, line it up on 35 degrees, and just make a mark. Now, from the tip of that vector to my mark, that's east-west. So now I'm going to reestablish what east-west is. Let's draw that line. That's east. Well, my actual vector is supposed to be south of east, 23 degrees south of east. So now that I have the east-west line, I'll lay my protractor back down, line it up there, and I'll find 23 degrees. 23 degrees is, there's 25, right there is a mark I made for 23 degrees. Now, heading off in that direction from the tip of the last vector, I want to draw a vector that represents 50 miles per hour. Remember, make my line, stop at 25 millimeters, and there's the tip of my second vector. So one vector comes down to here, the second vector goes there. Now, the sum, the resultant of these two, is just the vector that goes from the original origin to the tip of the last vector. So I'll draw that, and I'll measure its length. I'm going to start out with a 0 right there, line it up with the tip, and I draw this vector. When I measure it, I'm getting 128 millimeters. Well, in our scale, we double that. 128 would be 256. So I know that the length of my overall vector is 256 miles per hour. Now to get the direction, well, I can measure that too. So I lay my protractor back down here and line it all up with the origin. And when I measure the angle between my resultant vector and west, it turns out to be 44.5. That's how you can graphically determine the resultant of this vector.
Well, now I'm going to use a much more modern tool. In fact, this is I think this was just released this month. This is Google Sketchup version 8. And there are a lot of drawing tools that you can use for this. You may have one that you're familiar with or that you're learning about in a graphics class or something like that. Anything that can draw things to length, draw vectors, a CAD program or something will work great. And there are other programs that you could use as well. Smart, for example, that comes with smartboards, does this pretty well as well. Well, I'm going to start out by drawing a lot of things very similar to how I did it before. If I look at the problem, it says I need a 280 mile per hour vector, and it needs to be 35 degrees south of west. In order to measure that angle, I need a measuring device for angles, so I'm going to go to my Tools options here, and I'm going to select Protractor. And I'm going to stick this protractor at the origin, go out here and establish this. I'm going to call this west here, where I'm stretching this red axis out here. And click there, and then as I start to tip this, look at the lower left hand part of the screen. You can see that it's measuring what angle I'm at. So I'm going to go to 35 degrees and stop. So right there, 35 degrees, I'll click, and now I've established a line that's 35 degrees there. I'm going to draw a line segment, so I'll go up here, select my pencil, and then starting here I'll click, and then I'm just going to drag down that line until I go to where I want to go. I'm measuring in millimeters here, and I think I'm going to use a 10 times scale. So my 280 miles per hour is going to show up as 2,800 millimeters. So I'll get as close as I can to 2,800 millimeters. And where I'm zoomed here, it looks like 2804 is probably about as close as I'm going to get. So I'll stop there. Now, I need to draw another line segment. But the next line segment is going to be representing the vector that's 50 miles per hour at 23 degrees south of east. So I'm going to pull my protractor back up and lock on the origin again. And now I'm going to pull out east and establish my east line. And then I'm going to rotate down until I'm 23 degrees south of where east is. So it looks like it's right about there. If you're looking at the numbers, there's my 23 degree line. I'm going to draw another line segment. This is going to start at the origin, and now I'm going to stretch this out. Remember, I'm going 10 times more than what the speed is. So 50 miles per hour will be 500 millimeters. So 490.7, 499.2 is probably as close as I'm going to get. Okay, now I've got my two vectors established here. One vector is my plane speed, 280 miles an hour. This is my wind speed, the 50 miles an hour, and they're already laid out the way they need to be angle-wise. Now, here's what's nice about an electronic drawing program. I can just grab that vector. I didn't have to, do the alternate interior angle thing that I did before. I can just grab this vector and move it down there. So I'll select this vector, change its color. You can see that it's selected, and I'm just going to do an edit cut. Take it out of there and paste. Guess that's Control V, just like it normally is. And I'm going to paste it so that its tail is at the tip of the other vector. So that's what I drew before. Now to get my resultant, I just have to grab my pencil and I'm going to draw a line that starts at the origin and ends at the tip of that other vector. And it locks right on there for me nicely. To find out the size of that, I need a measuring tool. So I'm going to grab my tape measure tool from that point to the origin. If you look down here, it tells you what the length is, 2731.5. So at 10 times bigger than scale, that's 273 miles per hour. We also want to measure what the angle is. So I'm going to pull my protractor back up lock that on the origin. And I'm going to measure from west, so I'll pull out on the west axis, and then I'll just spin around until I lock on that line, click, and I look down here and I see that my angle is 44.1 degrees. So the results that I get are really similar to what I got when I drew it out by hand, but using an electronic thing like this, it's a lot easier.